Okay, I think we're good to start. So welcome everyone to the last round table of the day. This session will be on the topic of giving students active roles in learning. My name is Rebecca Bressot from McGill University, and I will be co-chairing the session with my friend and colleague, Dan Petrescu. So we have three speakers today, three panelists basically. The structure of our roundtable will be threefold. We'll start with a 12 to 15 minute talk from each of our speakers with no questions and answers at that time. We'll then direct you to the breakout rooms where you'll have a chance to choose the breakout room of your choice and speak directly with the speaker of your choice. And then we'll conclude with a panel discussion open to all panelists and all participants to ask questions in a more free-form manner. So our first speaker is Elena Boldyreva from the University of Toronto. She'll be speaking on improving students' understanding of the nature of science and supporting STEM identity development in a grade 11 biology class, a learning community approach. Our second speaker will be Leslie Schneider from Tufts University, who will be speaking on using collaboration technology to transform anatomy education for health professionals. And our third speaker is Tamara Western from McGill, who will be sharing about her experience with FSCI 396, which brings undergraduate students into the course assessment and design process, a course that I was very lucky to be able to be a part of. So before we begin, I just want to let you know that that we are recording this session. So if you would choose not to be on video or not to be recorded, you're welcome to switch your camera off and rename yourself if you'd like for more anonymity. You can use closed captioning if you would like. That's accessible in your Zoom controls. And finally, we ask that you mute yourself until the breakout rooms and the final session where the questions and answers can be asked. So without further ado, I will cede the floor to Elena Boldyreva.
Okay, thank you so much. I will now share my screen. And just a second. I hope you're able to see it. Yeah, thank you so much for accepting our proposal and inviting us to present. And 2 years ago, I was in Montreal in person. I hope it will happen again next year. So our presentation, James Slotta is not presenting today, so I will be presenting. My name is Elena Boldyreva. I'm from the University of Toronto, Ontario Institute for Studies in Education. I'm a third-year PhD student and also Ontario Certified Science Teacher. And my previous research is in biology. And I will be talking about our research. It is on improving students' understanding of the nature of science and supporting students' STEM identity development in a grade 11 biology class, a learning community approach. A little bit of introduction. K-12 students generally receive insufficient opportunities to engage in projects involving data collection, analysis, and collaboration, especially in science classes. Students often struggle when they're required to evaluate the arguments and conclusions of others in the science classrooms, or may not see the value in discussing other students' ideas. And students may have difficulty in developing a hypothesis, choosing evidence, and justifying why alternative explanations should be excluded. For nature of science, as some of you may know, the terminology is a bit variable. We are basing our study on this terminology. Nature of science is an understanding of how students work as individuals and the community, how scientific knowledge is generated and validated, and how science interacts with technology, society, and the environment. Understandings of the nature of science can be achieved through fostering student-centered discussions and emphasizing the importance of social discourse between students. And a learning community approach can support students' engagement in inquiry activities by adding authenticity and participation in the practices of science in the classrooms. We worked in the classroom in a with grade 11 biology students at a high school in Toronto. So this research is still in progress, but I would like to talk about our research and some preliminary findings. We were co-designing an inquiry curriculum with a biology teacher at the high school. There were 3 cohorts, 64 students. The Untitled Science curriculum consists of 5 units or 5 strands. In grade 11 biology, it is genetics, evolution, biodiversity, plants and animal systems. And in addition to addressing curriculum expectations, general and specific expectations of the curriculum, we added a cross-cutting diet and nutrition theme, and activities that we developed involved case studies, data analysis, and student discussions about credibility of primary and secondary resources. They were aimed at the exploration of the nature of science through students' evaluations of scientific findings, creation and evaluation of arguments. And also in each of the units throughout the curriculum, we included exploration of students' STEM identities. And I will talk about this a little bit later. In our study, we applied the KCI, Knowledge Community and Inquiry model, where students work collectively co-creating a knowledge base. We used Google Drive, Padlet. We used a new technology environment, Talkwall, which is not included here, and some other platforms. A knowledge base is used by students in each unit and in the next units, and students can add and improve the knowledge base that they are creating using these platforms. In this model, students work as a whole class, in groups and individually. A significant emphasis is on group work. And our goal in this study is that students participate in the practices characteristic of the real scientific community. We develop pre and post test of students' ideas on the nature of science, the role of learning communities, and career exploration to measure the impact of the curriculum. But as I said, some of the results, they're still in progress, and we are analyzing them currently because the research is not finished. Here I wanted to show some of the details. So as I said, in addition to addressing curriculum expectations, we added a cross-cutting diet and nutrition theme to make the curriculum more relevant for students, more interesting for them. And so we tried to include these diet and nutrition connections in each of the units. For example, in animal systems unit, we included case studies or discussions on nutrition diabetes. In the genetics unit, we included discussions of the real scientific papers on the obesity genes in selected populations. In plants and the use of plants unit, we included discussion of the issues of the use of pesticides when genetically modified plants production is carried out on the farms. In evolution biodiversity unit, we included diversity questions about diversity of our gut microbiota and coevolution, and many other topics that could connect all units together. And the culminating project again connected all units, and there were debates, or some students chose to do paper. And also in each unit, as I said, we included career connections. For career connections, students contributed to a career folder in each unit. So they connected the content of the unit and made connections to the professions in science, in biology, related, for example, to genetics, agriculture, study of the biodiversity, and so on. So data sources included collectively created documents, individual reflections, questionnaires, audio and video recordings, and classroom observations by the teacher and by myself. And students were progressively building the common knowledge base, such as, for example, here, this is an example of scientific argumentation that we tried in the classroom, argumentation about primary and secondary resources. So students worked in several teams and commented about the resources that they found related to the topics that we addressed in the classroom, or maybe the teacher suggested. And so they were commenting not only on the resources, but also on the claim, evidence, and reasoning and the quality of the arguments offered by other groups. And there was group work, also another example on the nature of science. It was more explicit learning about the nature of science, where students were sorting out statements about scientific theory, hypothesis, scientific law, scientific principles, and facts. And also we included case studies on nutrition and the risk of CVD, cardiovascular diseases. It is adapted from the Great Diseases by the Tufts University. Students were working with peer-reviewed papers, with the actual scientific papers. They were making predictions in groups, and they were co-annotating papers, and there were some other activities that we included. And here just some of the examples of the students' work. They worked in groups, making predictions about the paper, or annotating the paper, or looking for the claims that the authors make in this paper, and the evidence reasoning made by the authors. And as I said, one more component in each of these of the units of the curriculum was exploring students' STEM identities. So here students were working on creating, this is a Google Drive folder, and for each unit they had a separate folder here, but they can then they merge them into one folder. So here they contributed as a group to each of the documents. So they created document, for example, on the job of biomedical engineer, and they addressed the points that I added here. And students from a different cohort could also join this document and also contribute to this document. So they were adding more information to this document and had discussions. And so they were adding more professions, more parts of the document here addressing these points. Here I wanted to show some of the findings related, because as I said, we're still in the process of analyzing our data. Some of the findings related to the collaborative work on STEM career folders as identified by the students. First of all, students identified the following main themes, such as they said, there are many more careers that there are many careers that I really did not know about, or I may now consider a career in biology, or maybe they now have an opportunity to look at different careers and narrow their interest to the choice of the careers. And they could see how there are different ways that biology can be applied to the real world and industries, and other responses here. And we collected some of the student quotes also, where students look at how they, for example, can combine different careers. For example, students wanted to get a job in a justice system, but now is considering becoming a forensic DNA analyst to continue studying STEM. And here, questions that students still have about careers. We identified several themes. So we were happy that we introduced this activity and this opportunity for them to explore different careers. But they still had some questions after the end of the curriculum, such as on planning a career, paths to a future career, career and workload, resources where they can get more resources on different careers and jobs. Career integration, this was one of the interesting finding. And what is the job market for certain STEM careers, and career in technology, such as, for example, what if there will be robots everywhere in biology and medical sciences? So will there be jobs for students when they graduate? And I think I have to, I'm finishing now. So I would like to also acknowledge the support by the grants from Social Sciences and Humanities Research Council, and also from the School of Graduate Studies of the University of Toronto. Thank you very much for your attention, and I will be happy to address any questions you may have at the end of or in the breakout rooms and at the end. Thank you.
Thank you very much, Elena, for a really great talk. So we will be moving on to our second presenter. And I will be introducing Leslie Schneider from Tufts University, who will be talking about using collaboration technology to transform anatomy education for health professionals. So I'll be sharing her presentation, and we will be essentially co-presenting. I think you might need to unmute yourself, Leslie.
Can you hear me?
Yes.
Great, thanks. I'm on my phone, guys, so bear with us. Great.
Okay, so the presentation should show up. Yes.
Yeah, thank you. This afternoon, I'm going to tell you the story of how Tufts Medical School professors, and in particular, my partner, Krista Johansen, transformed their teaching to engage students actively with both the content and each other. They used an interactive collaboration platform called Visual Classrooms, along with carefully designed educational activities. The platform was initially funded by an NSF grant to Tufts University in Boston. Our goal was to find ways to give students an active role in their learning. Various departments at Tufts got involved early on, and one was the Department of Medical Education. Krista took the lead. Unfortunately, she can't be here today, but the cases I'll talk about are hers. I'll try to do them justice. Next slide. So just as context, after many years, medical schools are rethinking nearly every facet of physician training. The changes that they're making include approaches to both the content that students are learning and the pedagogy that they're using to teach them. Traditionally, medical education has featured standard lectures organized around basic science disciplines, plus a couple of years of clinical work. The newer approach focuses on integration. It tries to break down the barriers between science and clinical work and teach content using a thematic system-based approach with active learning instruction. Next slide. And you can click the things. As they move to this new approach, medical educators are increasingly turning to blended learning environments that feature both technology and active learning instructional strategies. Visual Classrooms is one of the technologies that Tufts is using to achieve its commitment to curricular integration and active learning. The platform features an interactive collaboration and discussion space, and unlike other platforms, students can express their ideas using media-driven tools, creating sketches, capturing screens, sharing videos, etc. Next slide. Our collaboration space supports scaffolded social interaction around students' ideas and artifacts. Students work together to ask questions, find answers, and make connections. The idea is that students learn better together. Both the student artifacts and embedded analytics in the system provide actionable, continuous feedback to guide and improve both teaching and learning. And the media options are available for students to participate in any way that is relevant to what they're doing and whether they feel comfortable with. Next slide. So the two big concepts that Visual Classrooms focuses on are student interaction and active instruction. We want to expose students to their peers' thinking, have them work in small teams, and capture complex ideas together using any media. Visual Classroom also provides tools for instructors to create engaging activities, to lead productive discussions, and provide feedback on the fly. Next slide. So the platform is flexible and is being used in a very wide variety of ways to support active learning. Some examples are interactive discussions, pre-class formative assessment, labs, virtual and face-to-face labs, problem-based learning, and even two-stage exams. Next slide. Again, as context, just so you know what Visual Classrooms looks like, this is an activity screen, the one that students see. Each of the blue boxes is a prompt that instructors create to give students instructions of what they're supposed to be doing. Next slide. This is a view of Visual Classroom's collaboration space. Students' posts are seen as what I'll call sticky notes on steroid. They're the little blue boxes. Unlike other discussion platforms, they're visual and media rich. And the research that we did during the NSF research project that launched this platform demonstrated that learning through these scaffolded conversations anchored around students' multimedia artifacts enables great, productive, student-centered discussions, promotes collaborative learning, and engages students in team-based, critical, and creative thinking. The next slide. So, how does Visual Classrooms work in practice? The first case I'll tell you about focuses on Krista's clinical anatomy courses and labs at the Tufts Medical School. Her goal in using the platform was to simulate the kind of teamwork that students would experience in the clinic. She wanted to see what students knew and how they were interacting with the material as they were doing it. She wanted there to be more collaboration and problem solving in her classes. She said she needed a more quote unquote real way of teaching, more clinically relevant. And that's why she began using Visual Classrooms. As context again, anatomy classes are essential to both medical and dental school education. They're mostly taught via didactic lectures with static radiological images. But as you can imagine, anatomy is about relationships. It's about 3 dimensions. And to actually interpret those images requires more than just memorization. So in this case, Krista used Visual Classrooms in a workshop format. Students were assigned to teams in an active learning classroom. You can see that picture at the bottom of the middle of the screen. They were presented using Visual Classrooms with radiology images and clinical cases that they discussed, annotated, and posted to Visual Classrooms. You can see Krista on the right-hand middle picture and students' annotations on the left picture. Next slide. So in addition to evaluating these images and cases, students were also asked to go further and apply what they were learning through what Krista called a curiosity challenge, where they had to find and post new cases to engage their peers. You can see her feedback at the bottom of the screen. So what did this do for Krista? What did it allow her to do? I'm going to read her words. Krista says that Visual Classrooms enabled her to provide a safe space for active learning, reflection, and social discourse to give her physician assistant students opportunities to test their knowledge and skills in a more clinically oriented manner. As well, the group work gave students the chance to examine this incredibly dense material from multiple perspectives. They often identified deficiencies in their knowledge and skills and resolved these with each other on the spot. Next slide. So with COVID, of course, everything went online, including labs. Instructors tried to replicate the station-based approach that they'd used in face-to-face labs. This is an example of an online lab. The blue boxes are the instructor's prompts, station by station. Next slide. And of course, in this lab, students observe images rather than.
Leslie?
Yeah.
I'm sorry, it's your mic became a little muted.
Oh,
Go
gosh.
the last 10 seconds?
No,
we're good now.
Okay, great. So in this lab, as you can imagine, students observed images rather than a cadaver and answered questions about them. You can see some of their answers on the screen. Next slide. During COVID, students worked in both Zoom and visual classrooms. Next slide. So in the spring, labs have been face-to-face at Tufts with social distancing, and students were able to move from station to station physically and record their observations on visual classrooms using iPads. The picture on the left is the prompts students needed to answer at each station. On the right is one prompt with student answers at the bottom of the screen. Next slide. Visual classrooms is also commonly used for case studies. This is an example of a case where groups of students are being asked to diagnose a vascular dissection case. And again, using the sketch tools on visual classrooms to annotate images and answer questions. So all of those markings in purple and red are students' answers to this case. Next slide. Visual classrooms is also used for unfolding or interrupted case studies, which I know some of you have used. In this case, student groups work through one section of the case, share their findings and questions with the class and instructor before moving on to the next case. This is the case of a 50-year-old woman who suffered a stroke. Next slide. And the interesting thing about this case is that in the first prompt, Krista added a video to introduce the case. However, instructors have also embedded virtual microscopes or simulations or other kinds of technologies into visual classrooms so that students can really actively interact with the material. Next slide. So pre-COVID, instructors used visual classrooms in lecture classes as well as active learning classrooms. This histology class is using visual classrooms for an exam review. Students self-organized in small groups and answered questions on visual classrooms, asked the teacher at the front of the room questions about the material as well. Next slide. In this activity, students answered multiple question types, multiple choice questions, as well as discussion questions where they identified processes using the visual classroom sketch tool and also to correlate structures and functions. So in the top picture and the bottom picture, you see pictures that the instructor has embedded into the sketch tool that students were able to draw on for their answers. Next slide. So visual classrooms has 3 question types: multiple choice questions, discussions, and this is a 3rd question type, concept maps, where students are asked to identify the relationships between concepts. In this case, students are mapping disease mechanisms, symptoms, and test results. And the next slide will show you an example of one person's concept maps. Next slide. So students really liked visual classrooms. I have a couple of their comments that I thought were really telling, explaining why. When studying dense material, it's natural to gain an understanding from just one angle. While we all hear the same lecture and view the same slides, every classmate sees the information through a different lens. Collaborative learning allowed us to obtain insight into how individuals comprehended various clinical cases and diagnostic images. The ability to share these perspectives with each other led to many aha moments. Personally, I can look at the same thing over and over again without grasping it, and all it takes is a new perspective to have the information click. Next slide. A few other comments, very helpful for me, helped me see whether I knew a certain part of the content. There were definitely things I missed going through the first time, and during the visual classrooms, it helped me see that, allow me to discuss answers with my peers and figure out the answers together, gave everyone a chance to speak. I liked the drawing and being able to go back and do questions over while studying for the exam. Krista did some informal research, although this wasn't really a research project, and she found that students using visual classrooms scored higher on midterms and finals when compared to a similar cohort who only received didactic lectures. Students demonstrated increased ability to interpret normal radiologic anatomy and began to recognize abnormal radiologic findings as well. Krista felt that she was able to create a learning environment that's more clinically realistic for students, and that students' engagement and interaction increased significantly. I'm happy to answer questions, and in the breakout session, we can also play around with visual classrooms as well. Thanks.
Great, thank you very much, Leslie, and thanks for bearing with us. This actually worked out.
Yeah.
Okay, thank you so much for the talk, and we'll be moving on to our last presenter, Tamara Western from McGill University, who will be talking about the FSCI 396 course at McGill that brings undergraduate students into course assessment and design process. And with that, I'll leave it to you, Tamara.
All right, I hope everybody can see my slides okay. This is very much remote learning. See if I can get her in the, anyway, my cat's here. Makes me feel just like I was teaching earlier this year. Anyway, so yeah, I'm really happy to be here. I really want to thank the organizers for giving me an opportunity to tell you about this course I've been involved with for the last couple of years, FSCI 396, that brings undergraduate students into the course assessment and design process. So I have a couple of quotes here on the screen that are things that I'm probably preaching to the converted, showing you these things, that learning is a thoughtful, iterative process, and that it's a partnership as well. So, oops. All right. And so teaching should be, I'm getting some feedback here.
It's not too bad though.
Okay.
I'm going to mute myself.
Okay. All right. All right, so if we look at the learning as a thoughtful iterative process, of course, when we think about our teaching, we start thinking about our teaching. How's it going? How can we improve it? We kind of get into the reflective teaching, and then we start looking into things and going to conferences like this one, and we move into scholarly teaching. And then we can move into the scholarship of teaching and learning, where we actually purposefully go in and start looking at the teaching and learning in our classes and ask questions and design studies, analyze data that not only can we use ourselves, but that we can actually share with others in conferences like this or in papers. So, but sometimes in scholarship of teaching and learning, you can spend a lot of time focusing on the problems of teaching and how do you bring in the students of the voices of the students and their viewpoint on this. And so we can get to the idea that learning is a partnership. Right. And one framework to look at learning as a partnership and move forward with learning as a partnership is that of students as partners in higher education. And I have a quote here from the book by Alison Cook-Sather and colleagues, that students as partners is a collaborative reciprocal process through which all participants have the opportunity to contribute equally, although not necessarily in the same ways, to different aspects of teaching and learning, be it in the design, the implementation, or the assessment of how things are going. And if we take another look at students as partners, you can see some of the things that come into the roles that students can play. Students as teachers to themselves, to each other, to us. Students as scholars in their discipline, in their interests, in looking at teaching and learning. And when you bring these together with all of these things that students do in their interactions with us and with themselves, with us, and with each other, students become agents of change. Okay, so what does this have to do with my course? Well, FSCI 396 is Research Project in Science, Teaching and Learning. It's an elective undergraduate research project course in the Faculty of Science at McGill University. And it is run by the Faculty of Science and coordinated through the Office of Science Education. So I'm a biology professor, I coordinate this course, and I also have some time I'm seconded to the Office of Science Education. So in FSCI 396, which we just tend to call FSCI, students work in partnership with faculty and staff to engage in the pedagogical literature and therefore in evidence-based methodology, and look at how we can co-design and inquire and assess into the teaching and learning in the faculty and into outreach as well, and therefore move into the scholarship and teaching and learning as a partnership. So why have such a course? Well, one thing is it offers another research opportunity to our students. Students are always looking for more research opportunities. There's often a limit in what they can do. And not only does it add an additional type of research that they can do, but not all students actually necessarily want to go into laboratory research. So this gives them a science-related research opportunity that they can take advantage of. The other thing is by investigating and looking into the research literature into how to improve teaching and learning, and having these conversations between students and faculty and staff helps improve the teaching and learning in our courses and within our faculty. Next, it actually helps facilitate scholarship of teaching and learning in our faculty, both in terms of there's now partners who will work with our faculty, most of which have their disciplinary research lab or projects to run as well. And so this gives them the opportunity to start to do some research into their courses with a partner to work with them, someone who is very invested and can bring a different viewpoint. And also, because we're starting to have these conversations within the course, within the cohort of students, between the professors and the students involved, and we start talking to our friends and their friends, and it kind of helps facilitate a community, a learning community on teaching and learning within the faculty as well. So what actually happens in FSCI 396? Well, I run the course where all the students come together as a cohort, everybody who's taking the course in that term. And this is a bit like having a lab meeting with everybody who works in your lab. And we have weekly meetings with me, the full set of students, with what supervisors, faculty and staff that can make it. We also have some outside experts come in, and we have workshops on pedagogy and methodology. So remember that the students taking this course are BSc students, and for most of them, their knowledge of pedagogy is from being on the student side of the equation. And we have discussions on the pedagogical literature and journal clubs. Sometimes we spend a meeting working on tools in a collaborative fashion. There's individual meetings of students with the faculty and staff supervisors who may be involved with their particular project. And also students perform a research project where they do everything from looking into the literature that's related to their project. They write a lit review, they write a proposal, they collect and analyze data. They may do a simply analytical type project. They could be more getting into designing something that is evidence-based. They prepare a final research report, and then finally they do a presentation on their research. Initially, we first did this within the group, but more recently we've been starting to open that up to other people. So How's this been going? So this course started in winter 2019. It's been running 3 terms a year, so fall, winter, and summer. And thus far, we've had 42 projects completed. Some of those have actually been students coming back to do a second project. And I'm happy to say that some of these students are also getting involved with other education projects after working in the course. The students are represented from 12 different academic programs across the BSc and the BASc. And we also have faculty and staff involved from a number of departments as well. Most of them are from Faculty of Science, but also from the Faculty of Medicine, where they do some teaching within our Bachelor of Science program. And we've even had a professor from education involved in the program as well. So what sort of projects do we do? Well, I already alluded to the fact that projects could be more designing something, an active learning project, an outreach project that in an evidence-based manner, getting into the literature. And then it could be assessment of something that's being used in a course, an active learning technology, an active learning tool or resource that's provided to the students in a class. It can be based within a particular course. And you can see here a number of courses are indicated. Sometimes they're courses that just do kind of a one-off thing, or others have been done multiple projects. So an example of this is Biology 301, which is a large undergraduate lab course that was recently converted from more of a cookbook course to more inquiry guided course. And so there's been several projects in Biology 301 documenting and following that change and how the students feel about it. There's been projects related to outreach. There's been projects related to the Fresca student collaborative learning community. There's a recent project done in the Faculty of Medicine looking at the design of a faculty peer-to-peer coaching program. And so there's a lot of different type of projects that people have done. And of course, last fall, we did a big remote learning project in a lot of our big courses. So now I want to just give you a taste of a couple of the projects that we've done recently in the course. So there's 2 projects I'm going to show you. So one of the things that I've been really thrilled about is that these students, after they take FSCI, then they sometimes go and present what they've done in other venues. So for example, the 2 projects I'm showing you right now are ones where the students decided afterwards to participate in the undergraduate poster showcase at McGill. And so this is the poster from Sam Richet from, this is his fall 2019 work. And this is talking about his work in Biology 202, which is a very large introductory genetics course. And in the course, what Sam was studying was the students' perceptions of some different active learning or course resources that we put into the course, and seeing what the students' perceptions of them, whether they found them useful for their learning. So this is an example of just one of the things in this course. And this is a cystic fibrosis case study, which essentially was a longitudinal case study that we used across the course, both to demonstrate how genetics works at different levels in real life and how it is relevant to our lives by looking at a particular disease. But also we tried to use it to tie together the fact that this course has multiple instructors. And what Sam did was we had run a survey asking students whether they thought something was helpful. And so we both had quantitative data, but we also had open-ended question responses, which gave us a richer view of what the students really thought and why they thought it was useful or not to them. And so this is showing the coded data that he got out of the open-ended questions that he coded into themes. And you can see here on the left, just their general opinions. And at the bottom here, the green bar, you can see that all in all, they pretty much liked the case study. They found it useful. And when you break down their positive comments, one of the things that they brought up over and over again was the fact that they found them really useful to illustrate what we were learning in genetics and how it relates to real life, which we were really pleased about because we didn't tell them this was one of our plans. They just came up with that in the answers. So we're so thrilled. Another thing though, in terms of the negative comments, they said, okay, well, it wasn't that integrated into some of the lectures in the course, especially in the later part of the course, which is good. That gave us something to work for. And we actually had a student follow up and try to better integrate it. So another project that I alluded to is the large remote learning project we did last fall, where I had a cohort of about 12 students in FSCI, and 10 of them were working on this big project where we were looking at student remote learning experience in our very large freshman and core courses in the Faculty of Science. And so this is the poster that Sarah Levy, one of the students who worked with me last fall, put together on her work studying the remote learning experience in Math 133. And once again, we used a survey. It had both quantitative data looking at student engagement, their motivation levels, how they felt about remote learning, challenges they found with remote learning, and included both the quantitative data, but also, once again, some questions so we could get a richer data set to see what students are thinking, kind of how they're thinking. And so Sarah coded hundreds and hundreds of answers. And one of the themes she came up was personal challenges. So these are things you've probably been hearing over and over again in the remote learning context, but lack of motivation, difficulty concentrating, difficulty engaging, social isolation. And then here are some of the comments that were used and related to some of these codes. Less motivating to work online. A large proportion of my motivation and desire to engage comes from face-to-face interactions with peers and professors. Remote learning isn't as effective as in-person teaching. It's very difficult to stay focused in class at times. Right? But in addition to looking at the remote learning in general, she also took a look at some of the themes more related to how this particular course was able to pivot into remote learning. And so there were some things that students liked, shown here in green. They liked having the recordings, especially in a math class, which often are taught just chalk and talk on a board. Here they have recordings so they could revisit things again. They found the course was well organized. It was easy to find resources. On the other hand, they found that the workload was stressful. There seemed like there was a large workload and a lot of assignments. So in general, things went well, but there's some things to think about when this course is given again, either in person or hopefully not remotely completely again. So finally, I want to say I'm extremely proud that 4 of my FSCI alumni are actually presenting at this Saltese conference. You may have seen some of their presentations already earlier today. So Megan Pepin and Claire Norman both did posters, and Megan, they both worked with Maxime Denis in biochemistry, and Megan designed e-learning projects or assignments for a biochemistry course that went very well. And Claire Norman was looking at active learning perception in biochemistry courses. And this morning, Whitley and Iris both talked about our collaborative learning Fresca community, where Iris had studied it in person and Whitley studied the pivot to online. And though almost all of these presentations have already been given, Iris will be speaking briefly as part of the symposium tomorrow morning on the future of STEM education. And finally, there's so many people I need to thank with regards to this course. Most importantly, all of the students who have been involved in this course, they have taught me so much. They have been so impressive. They've done so many things, had so many insights. It's just an amazing experience working with them in this course and talking about teaching and learning with them. And then also all of the collaborators, the faculty and staff and graduate student supervisors, collaborators, workshop leaders, and my colleagues at the Office of Science Education. So thank you to everybody. And finally, I'm really happy to talk to people about this course in the breakout room. So thank you for listening to me.
Thank you so much, Tamara. Just as a little side comment to this Students as Partners program and my involvement with Tamara's FSCI 396 class is one of the main reasons that I'm currently doing a master's in education. So the growth and the potential for students after this program is incredible. We will now be breaking up into our breakout rooms. You should see 3 breakout rooms pre-prepared for you to join. assigned by the last name of the presenter. If you have any problems joining your breakout room, please speak up, ask, or put it in the chat. Ask Dan and I to assign you. Leslie, I think we can, okay, sorry, taken care of. And yes, you'll have 12 minutes to speak with the presenter of your choice. You're welcome to bounce around. You're not married to a breakout room. You can go see multiple presenters.
At that, and, you know, encourage the students to speak up and make it a safe place for them to do so, right? And that, and I guess also make it clear that everybody has something to contribute, you know, and this both is kind of, you know, fostering kind of the growth mindset, but also the fact that everybody has different experiences and different things to bring to the table that, you know, really enrich the, you know, the learning process to bring these different things in.
I think that's a good point, and that's been the challenge with active learning, that students really are used to sitting and listening. And what we've found is that with practice, students are very happy to participate, and Visual Classrooms really encourages that.
And we also talked with Lorraine in my breakout room, that all the situation that we're still teaching and learning online. This is a challenge, but let's look at the opportunities. Let's explore these opportunities. And when hopefully we'll go back soon to the normal life, let's not forget those opportunities. All what we explored with different platforms, with different media, with different technologies, with different ways of communication, listening to students, assessing students, this is very important. So when we go back to the normal, let's keep this all in mind as our strategies and incorporate it in our learning co-teaching.
That's very true. There has, I mean, anyone from, I guess, teaching and learning services anywhere can tell you they never had so many clients and discussions in their lives as they did in this last year. But one of my great hopes is that some of these new ways of assessment and getting beyond memorization and all of these things people have been doing to foster engagement and interaction online that they never did in the classroom, I really hope that those things, you know, remain. And that's something I'm actually interested in looking into and following as it, you know, happens at McGill is, you know, what do we retain or hopefully retain?
There have been some positive points to the last year. Do we have any more questions from our participants?
It's the end of the day.
It's the end of the day.
Yeah, and I just wanted to thank the organizers, everyone. This is so incredible that you were able this year, because last year we missed this opportunity. 2 years ago, I was in Montreal in person, but I hope we will be all visiting next year. But thank you so much for being able to organize it this year. This is incredible.
Yeah. Well, thank you. I really enjoyed everybody's talks, and thank you for asking questions and things like this. This is such a great opportunity to talk with people. And
yeah, Dan and I have been saying that after a long year of rather isolated advances in education and teaching and learning, it's so nice to be able to come together as a community during this conference and just know that our learnings have not been really in isolation, and we can share them. So thank you to our three presenters, and thank you so much for a long day of the second day of the conference. You're free to go. I invite you all to join GatherTown and take part in the live music and games on the rooftop if you would like. If not, we hope to see you tomorrow for the last day of the conference. Thank you so much.
Thanks to you.
Everybody.
Bye, everyone.